Okay, well, welcome back. This is part two in our series and part two in our discussion of images. And in this video, we're going to kind of extend what we talked about last time, where we found that an image is basically comprised of three sub-images, grayscale sub-images, and each of those sub-images defines how much red or green or blue is in each pixel. And it's basically, as you know, a computer doesn't know anything about colors, it just knows values and numbers. So it provides, in the form of what looks like an image, is basically just a matrix of numbers. So you're providing information to the computer about how much red, green, and blue in three separate images. And we saw that you can extend that to provide all kinds of other information to the computer about the image and how you want it rendered onto the screen. And we showed that you can add one more channel, which is another sub-image, and that's called an alpha or transparency channel, and it provides a grayscale image again that tells the computer how transparent that image is at each pixel. And in this video, we're going to extend that to talk about even more data that you can pack into that image file, grayscale image channels that provide, in this case, we're going to talk about depth information, how far away each pixel is from the camera. And but first of all, we're going to start with kind of a little side journey to see exactly what is inside an image file. Because if you're going to be importing images into your renderer, you really should know what's inside the file, because you're going to have to know what the format is and what's actually the numbers and what do they represent and that kind of thing. Even if you use an external rendering library, you really should know what's inside the file so that you can understand what the data is. So what I'm going to do is I'm going to jump over to GIMP. And like I mentioned before, I love GIMP. And it's a wonderful way to make our own images and tweak them and modify them and see what that really means in terms of the renderer and whatever software. And this is a really good example of how I can make a very simple image and look at it, look at the file that it generates, and see actually what shows up in the file. So what this is I made a 10 by 10 pixel image. Now, normally it's like this tiny. It's a little tiny image, but I'm zooming in, and each one of these squares is a pixel. And I show a little grid here to make it easier to see. And this 10 across by 10 down image of 10 by 10 or 100 pixels, you can see that most of them are white pixels, and there are two that I colored different colors. So what I want to do first is try and see if we can figure out what's going to be in that image file that represents this. I'm going to export it as a bitmap, and we're going to look at the bitmap. But before we do that, I want to kind of guess what it's going to look like just based on what we see here. So as you can see, I've got 100 pixels. All but two of them are white, which means there's 98 white pixels, and two have these colors in them. So what is the image file going to look like? Well, if I take my color picker and I click on a white pixel, you can see that the value it shows for that is it's got 255 reds, 255 greens, and 255 blues. All right, that is what it takes to get a white pixel. And what this means is I've got full red, full green, and full blue. Now, why is 255? Well, each value in this pixel, in this bitmap, is described by 8 bits. A byte, which is comprised of 8 bits. And if you remember your bits and bytes, each bit can be either 0 or 1. So 1 bit gives you 2 possible values. 2 bits gives you 4 possible values, because you can have 0, 0, 1, 1, 1, 0, or 0, 1. And each bit you add gives you 2 times more possible numbers you can represent. So an 8-bit value gives you 2 to the 8th, or 256 possible numbers that can be represented. And that's why we have 255 here, because 0 to 255 gives you 256 values. So we can represent this red value by an 8-bit number, all right? Same with the green and same with the blue. So now we know we've got, for each pixel, the file is going to have 3 8-bit numbers to represent these. So why are we using 8-bit numbers? Well, 3 8-bit numbers is 256 times 256 times 256 possible values. And that comes out to like 16 million possible values that you can represent with those 3 8-bit numbers. So that's 16 million possible colors, and your eye can only discern like 10 million. So for most people, it's more than enough to describe just about any color you can think of and any color you can see. So now we know we're going to have like 98 3-byte numbers in that file, and we're going to have 2 pixels with numbers that are different from those 255s. Now, keep in mind, when we said 255 for each of these, red, green, and blue, the hex version is FFFFFFF. That is the representation of all ones for the 8-bit numbers. So we're going to look at a bitmap which is going to be in hexadecimal form. So we're going to expect to see a lot of Fs, right? Because it's all, that's, each number is FF, which is 255. Now, these 2 are going to be different. And I'm going to click on this one, and I can see that the red is 0, the green is 48, and the blue is 50. And if we look at the hex number down here, we get 00, 30, and 32. And then if I go over here at the blue, we get 48 red, 110 green, and 236 blue. And that comes out to 306EEC. So if you don't believe it, we'll take out the calculator and we'll enter, for example, 30 and see if it comes out with 48. So 30 hex comes out to decimal 48. All right, so converting 30 to 48 hexadecimal works out. And if I go from 6E gives me 110 decimal, and that's what we get here. So we will expect to see these hex numbers in the file. So we know we're going to see a lot of Fs. We're going to see 98 pixels worth of Fs, and then 2 with these hex numbers. So I'm going to look at the file. Here's the file opened up in Notepad++. Now, I mentioned before Notepad++. It's wonderful if you're a coder. It's good. You can put in different languages, C++, C#. You can look at code directly. In this case, I've got the 32-bit version of Notepad++, and I've got the hex editor plugin. And it's only available in the 32-bit version, so I recommend you get that. And you can take the bitmap, it's a .bmp, and load it in and run the hex editor, and you will get this. And it will show in hex the contents of that file describing this, this image. So if you go to these first group of lines, this is all header stuff that we're not going to worry about. But if you start here, you can see, wow, there's a whole bunch of Fs. All right? So we said, yeah, that makes sense because all these Fs are FFFF for 255s, and that's what we're seeing here. And it turns out we've got, across here, there's 16 Fs, and then there's 20 down. So 16 times 20 is 320. And we said we would have 3 times 100, or 300, because 3 bytes or 3 numbers, red, green, and blue per pixel, and we got 100 pixels, so 3 times 100 is 300. Now you'll also notice there are some zeros in here. Those are just kind of buffers that we can ignore. So we just pay attention to these F's, and you can see right here there are some different numbers. 306EEC and 303200. And if you recall, 306EEC for the blue, and there it is, 306EEC. So it makes sense now. We've got all these F's for the white, and then this for the blue, and then this for the reddish blackish number. So now you can see how we can make a very simple image and actually look at the contents. So now maybe we're not so afraid to not understand what's in a bitmap image or any other image, because it kind of makes sense. So now in the previous video, we showed how you can cram some more information into an image file in the form of an alpha channel, which is basically another grayscale image that defines how transparent each pixel is. So let's say we wanted to do that here, and we wanted to see what does the file actually look like after you've added an alpha channel. So what I'm going to do is I'm going to go in, I'm in same image, I'm going to go into the layer here, and I'm going to select Add Alpha Channel. And I jump over into the channels, and you can see now I've got a new alpha channel. And what I'm going to do is I am going to add some transparency in this alpha channel. The way I do it is I get an eraser tool, and I select this, and I just start erasing. Okay, so now I've got these 6 pixels, and I'm adding transparency to these pixels. And now what I'm going to do is I'm going to export them, export this image as a bitmap that has an alpha channel, and look at it in Notepad. Okay, so here is the image file, the bitmap, in Notepad++, and this includes the alpha. And here's the previous image, and you can see here's the new image. It's got a bunch more data. It's got the same header, but it's got a bunch more data with the FFFs. But you can see interspersed in here, you've got 02, 04, 0E, but still mostly Fs. So what has happened is now instead of, remember in this last one we had a color as 306EEC with the red, green, and blue for a pixel. Now it's instead of 3 numbers, it's going to be 4 numbers. Because the 4th number is going to be the alpha value. So that's why we've got more lines of code here, because we've got the alpha channel values appended to each RGB. So we've got an RGB FFF with an alpha of 02. Here's our original color. This was the blue color, I believe. And we have the red color up here, or the black color up here. And the rest are the whites, and they've got some alphas. So basically just adding on a single digit, a single byte of alpha values. And here we've got 02, 04, and 0E, and 22, and 0D. So wherever it's a transparency, you're going to see a number other than FF, because FF is fully opaque and no transparency. It's a white value. So you can see that when you add the extra channel, you're just appending an additional number onto the RGB values to show what the alpha is. Okay, so now that we're comfortable about adding additional data in the form of an alpha channel to our image to define how transparent each pixel is, let's look at other types of data that we can add to tell the computer how to render our image. When you get into 3D rendering, you're going to get a lot of exposure to to things like this, adding additional data. And when you're doing 3D compositing and rendering, there's a lot of data you can add to an image to define how you want it ultimately rendered. So what we're going to do is we're going to take this image where we've got a render of a fighter on a background photograph, and let's say we want it to look so that it's kind of like it was a photograph taken with a camera, and there is what's called depth of field. In other words, the further away the subject is, the more blurred it is, and the stuff that's closer is in focus. So what we want is something like this. And this is a horrible example. Blender is not real good at doing depth of field, but this at least gives you an idea. Stuff that's near to the camera is in focus, and stuff that's far away is blurred. And to do that, what I did is I made an image, or actually a mask or a channel, but basically a grayscale image that defines by its values, by its black or white or grayness, how far away each part of the image is from the camera. So you can see these mountains are real far away, so I use this image right here to define that depth information. So the mountain, which is far away, has got a black image, and if it's closer to the camera, it's more white. And there's a transition, a gradient. Okay, so you can start to see that here's just one more case where all I have to do is generate an image by hand, generate a gradient, and it will be, it can be used by the computer to give information on how far away the each pixel of the image is from the camera. And of course you can do a much better job than I did. I just did a quick gradient. But you can see where you can start adding a lot of different information to define how you want the image rendered. And you can do it manually, or when you're doing a 3D renderer, information like this may be automatically generated. Like if you're doing ray tracing, it automatically generates information on every point in the scene, every pixel, how far away the object is from the camera. So you will get what's called a depth pass for free, and you can use that depth information to feed into your compositing or your rendering software to automatically do a depth of field blurring effect. So again, there's a lot of ways that you can use additional data packed into the image, and it's basically just grayscale values that define to the computer different information about your scene so that it can do fancy things when it's doing the render. So I hope you're starting to get the sense that grayscale images are really, really important in 3D rendering and graphics. You're going to see them a lot in many different areas. We've seen them with transparency. We've seen them with depth. You're also going to see them with materials, like surfaces, how bumpy, how shiny a surface is defined by grayscale images. So just keep in mind that a lot of what seems like magic in compositing and post-production and 3D rendering, a lot of it comes down to grayscale images providing information to the computer. So just keep that in mind and get comfortable with using grayscale images in your work. Now I think in the next video we're going to start to move into 3D objects. And we're going to build simple 3D objects in Blender, and we're going to export them and open them up like we did with these image files. Open them up in Notepad++ and actually look at the text of what an object is and what comprises an object, and that's all defined in an object file. So that's going to be very important when you're developing a renderer and you have to load object data and material data into your scene. You're going to need to know what's in the file, what really is an object, the vertices, the indices, the materials, the normals, all of those things. You're going to have to understand what they are, and you're going to have to know where they are in your object file so that you can format everything in your renderer. So I encourage you to hang around and watch the next series of videos. Otherwise, take care and have a really good day. Thanks.